Hello, can you guys hear me? How's everyone going? Yeah, sick. Great. Welcome to my talk. Don't reinvent the Geth wheel, or sandwiches taste better when someone else makes it. This is going to be a talk about Geth tooling, so how you don't need to keep creating new tools to recreate internal APIs that Geth already has. So yes, I am a library.ethereum virtual machine. I am a mempool inspector. I'm a sandwich connoisseur. And I'm here because I wanted a free ticket. And I submitted 2 talks, so I'm here twice, apparently. So yes, hello again. I don't claim to know everything, so please honk at me if you find anything wrong with the slides. I know I'm standing on the shoulders of the giants. I know there's some Geth developers here and there. I'm merely a Geth user. I'm not the creator. So please honk at me if you find anything wrong on my slides. I know everyone's very partied out. It's everyone slept at 5 a.m. and it's 11 a.m. So take your time, by the way. Yeah, let's talk a little bit about numbers because everyone seems to like them. Big titles, big numbers. Let's go. Does anyone know how many euros worth of MEV has been extracted? Actually, this is a little bit out of date. This was done when 1 euro was 1.2 USD, so it might be a little bit different now. But does anybody know how much euros has been extracted from MEV since the inception of flashbots? No? Well, I can tell you it's roughly 550 million times 1 divided by 1.2 million dollars worth, million euros worth of MEV has been extracted, or about 0.6 of an Andre, you know. So yeah, that's how much money has been extracted from MEV. So if you want a slice of that, yeah, please continue to listen to the talk. And yeah, and I know about 100% of those the value extracted from the MEV are being extracted by people who are not in this who are being extracted by people who are not in this room. I mean, if you guys could extract value, why would you be listening to my talk? Yeah, so I guess the issue with a lot of these MEV searches, if you will, is that the average perception of a MEV searcher is like, so you have all these like complicated jargon that people think you need to be some giga chat, giga brain to kind of even compete in the playing fields. Like this guy who kind of dealing some guy who says everyone has been dealing with poor coders your whole life. If you can't process 50K pairs in 20 milliseconds, you're not worthwhile of being a coder. And I just want to say that that is not true at all, because the average searcher that I've encountered makes calculators like so. So that is a Python script. That is actually the average MEV searcher. It just works. It works good enough. It doesn't have to be the best solution. You don't need to filter through 50K pairs. You can do 2 pairs. If you're really good at those 2 pairs, you will always win those 2 pairs. It doesn't have to be generalized. It can be application specific, just like this calculator. It has about 20,822 lines as an addition calculator, so it works approximately for about numbers 0 to 10,000. So if you do addition within the ranges of 0 to 10,000, this calculator will work, just like your MEV bot. Yes, so this is a real-life example, by the way. So my good friend, Tall God PvP on Twitter, you can search this up. You can even look up the keywords. This is all on the Twitter chain. He has a bot that's been printing money, and it is a single file Python script that is roughly 12,000 lines long. A single file. Let me reiterate. A single Python script that is about 12,000 lines long is printing money, and you are not printing money. Please, what's happening? So yes, you might ask, why am I here today? I am here today for a free ticket. Yes, for a free ticket, and because everyone has been messaging me on how to get started. I get like all these spams every day on my message requests. It's like, oh, how do I get started? If you help me out a little bit, I'll give you 50% of my loot. And yeah, so that's why I'm here today. Teach you how to get started in this very opaque world, just like TradFi. And also to teach you how to get a real job, So if you can't describe your job in 3 words, it's not a real job. Let me reiterate. If you're a SaaS-based fintech sales analyst, it's not a real job. If you create systems to record blockchain data, that's not a real job. But if you do MEV, that's 3 words. That's a real job. Oop. All right, so unfortunately, this talk only works with Geth. It doesn't work with all the other cool tools like Parity or Infura or Alchemy or all the other RPC providers. It only works on Geth. So that's the caveat of the talk. So as Gavin would like to say, give me Geth or give me Def. So let's go. In fact, we'll be focusing more heavily on Flashbot's MEV Geth, which is which if you look it up, if you look up the contributors, I actually contributed a piece of function there. So yes, my name will be in the contributors list. So if you'd like to donate, like and subscribe, thank you very much. That'll be greatly appreciated. Yeah, so these are the Geth features, lesser known Geth features that I would like to go over. The first will be state overrides. The second will be a module called the debug tracer, and the third will be like GraphQL. I don't know. Does anybody even know that Geth has GraphQL? Yes, or a few people, or you guys probably know it even better than me. But yes, we're all here today to learn, stand on the shoulders of the giants. So state overrides. So I guess the issue that you would like to that I encountered while doing MEV is okay. So how do I test new contracts? When I have new contracts, it's easier on Polygon or like the L2s because it's a lot cheaper. But if you have a contract on L1 and you would like to test if it's actually working, yes, you could fork the mainnet and try and do some testing, but that doesn't really give you like a production-like environment. When you're doing arbitrages, these opportunities come and go very instantly. So how would you test that? You have a smart contract and you have your bot logic. You can't really. It's not really economical to deploy, well, back then it wasn't economical to deploy contracts every day when gas was at 250 Gwei and then ETH was at 4K. Well, these days it's a lot cheaper. But back then it was a lot harder. And so, yeah, how do you test your contracts? Oh. Yes, yeah, and also the problem is Vitalik's law. You know, the closer you are to deploying a contract, the higher the gas fee goes. So yeah, as we all know, so state overrides will help you negate that. So before I had, so state overrides is actually a lesser known feature in the RPC API called ETH call. And ETH call actually, as I'm just reading from the description, it executes a new message call without creating a transaction on a blockchain. So you do like read states, but and so an example would be if I would like to execute a transfer function which returns a success, I could actually use ETH call to kind of simulate that method to see if that transfer method will be successful. So this is one example where I'm calling the ETH call transfer function and I'm trying to transfer roughly. I apologize for making everyone read this very badly formatted JavaScript code at 11:15 a.m. after everyone partied. But yes, so this would be an ETH call example where you try and simulate a call to a contract address, which could be like USDC, any ERC20 contract USDT, not USDT because it's not standard, but DAI, USDC, WEF. You could simulate this transfer function to see if this function would return you a value. But did you know that you can actually specify a third object? So there's 3 data blobs, 0, 1, 2, from to data. But you can actually specify something called state and state diff, and even code and nonce if you want to go into the little nuances. So state is essentially a fake key mapping value to override all slots in the account, and state diff is fake key mapping values to individual slots in the accounts. There's a little bit of a nuance there, and I know it's really hard to wrap your mind around it. So I'll give you an example, and maybe it will become more concrete. So let's say you want to you want to override a new contract where the transfer function always returns true. You can do so at address 0x42, assuming you're calling to address 0x42. You can specify, hey, at address 0x42, I would like to deploy this. I would like there to have this contract bytecode. And then the state difference, for example, let's assume slot 0x0 contains the balance of my token balances for the ETH account address or whatever. I can specify that account has maybe like 100,000 tokens or something like that. And at address 0x42, will contain this blob of code. So you don't actually have to redeploy your contract every time you would like to test, every time you want to test a new contract. You can just simulate it with Eve call. You could do a little bit more fancy stuff with this because now you're not dependent on like the main state. You don't need to like simulate a bunch of like, you don't need to bundle up a bunch of transactions to reach the desired state. It can be done in one call and in one blob. Very useful. The next up would be the JavaScript tracer. Does anyone know there's a JavaScript tracer in Geth? No? Okay. So does anyone remember Salmonella? Salmonella, for anyone who doesn't know what Salmonella is, it's essentially a poisonous token that you can buy but you can't sell. And so a rough pseudocode on how this worked, not the exact implementation, by the way, would be that the Salmonella token inside the transfer function, it would check if the Coinbase or the miner of the block was the hard hat testnet address. So if the hard hat testnet address was detected as the miner, the transfer function would work. But if it wasn't, if it was a real mainnet miner, then the transfer function would fail, meaning that potentially you could buy, but you couldn't sell this token when it came to mainnet simulation, to mainnet mining, but it would be successful in mainnet simulations. So that would be like one example of how you could create Salmonella, a Salmonella derivative, if you will. Again, I apologize for making you guys read this very badly formatted code and such on the third day of the live event, but we're all here, so let's just go through it. So you can actually specify there's a RPC method called debug_trace_call, and with debug_trace_call, you can trace the transaction you're about to be doing and extract out specific opcodes. So for example, I could extract out if within this transaction, I see the opcode Coinbase, difficulty, number, or origin, then this to me, this transaction is very suspicious. Because why would a ERC20 transfer function contain Coinbase? Why would it contain difficulty? Why would it contain number? And why would it contain origin? Because we're deviating from the norm. We're deviating from the implementation, and we're deviating from the standard. Like this ERC20 token is extremely suspicious, and now I can automatically append it to my blacklist, if you will. Or you can only append things to your whitelist, depending on how you want to structure your logic. So debug trace call, very, very, very useful tool if you want to automate a lot of these automate like poisonous token checkers or other stuff, which I do not think we have time to go into today. And the third one would be GraphQL that I would like to talk about. So Geth actually has GraphQL built in since EIP 1767. I do not keep track of the numbers. I merely Googled GraphQL Geth, and that EIP popped up. Yes, it's been there since 2019, so it's been a good 3 years. Yeah. And the features there are extremely powerful. This is how you invoke it. You have the, when running Geth, you add in the HTTP flag and the GraphQL flag, and you would get Geth with GraphQL. Again, so this is an example on how you would use GraphQL on Geth, assuming that your Geth RPC node is running on localhost at port 8045. There would be a GraphQL endpoint at the end. So you can specify a GraphQL schema and retrieve out some data blobs. Let me just see what the next slide is. And you might ask, why would I even care about extracting? In this example, I'm extracting the storage slot 0x8 on the Sushi WEF USDC Uniswap V2 pair, and the Sushi Swap WEF USDC pair, as well as the Uniswap USDC WEF pair. And on slot 0x8, what that contains is the reserve values for the Uni V2 pairs. So with GraphQL, you can actually extract out you can batch extract the reserve values from any Uni V2 pair or any Sushi Swap pair to do your analysis. For example, arbitrage analysis, is this going to be profitable? Like, because you need to keep updating it every block. Like, this is a very rudimentary example, because you would actually, and in reality, you wouldn't be loading every single pair at every single block. You would be only checking what changed each block before reading from the new reserve values. But if you would like to do like a cold start where you read every single possible pairs, for example, in Pancake Swap where there's 50,000 pairs, you could definitely do this. And UniV3 ticks, or however you want to pronounce it, if you would like to extract the data from each tick, it gets pretty convoluted, especially in pairs that have very high liquidity. For example, very high liquidity. For example, the WEF USDC pair. If you would like to extract all the tick data out to do some kind of analysis, you could also use this method. So you can read from slot values directly with the GraphQL pair, with the GraphQL API. In fact, it's extremely powerful. It's just I don't think I'm doing it justice right now, because there's so many more features that's hidden behind the scenes. But I personally haven't used them, because this is the only thing I use when doing arbitrage. Yes. I realize I'm running really quickly, probably because I'm very sleep deprived. But some parting advice for everyone: buy programming stocks. It really helps. Yes, you get 10 points in intelligence and dexterity. Yeah, in fact, it's a combination when you buy the C programming book. So please, yes, you can also buy them from weep.store. Yes, any questions? Went in really quickly, but yes. Yes.
When you use the trace, for instance, for a sandwich bot, do you run it all in advance and whitelist pairs, or do you run it in real time just before you would do the actual arbitrage transaction to see if it's not a salmonella token?
It depends on your risk appetite. So personally, I like to have a white list, not a black allow list, not a deny list, if you will. Simply because I do not feel comfortable losing that amount of capital just from one mistake. So I would manually allow whitelist the tokens. We would check like, okay, how much volume is being done against this token, how many opportunities, and we kind of go in and manually like handpick like the top, let's say like 20 tokens that could have, that might give us an edge. It might give us an edge. So we only do like whitelist because that's our risk appetite. Yeah.
Okay, thank you.
See everyone's speechless, just as I am. Thank you very much for your time. Have a good rest of the conference.